Testing. Hello, can you guys hear me? Can you hear me?
Yes, sir. We can hear you.
Okay, perfect. It was looking like my audio wasn't connected, so I was trying to make sure everything was up and running. All right, so good evening, everyone that's here. All right, so I'm just going to start taking down your names as usual. All right, so welcome, Veronica.
Hi, good afternoon.
Good evening. How you doing?
I'm fine. How are you?
I'm doing well. Thank you very much. And Jacob, see you're here as well. Welcome, Jacob. All right, Alma. Good evening, Alma.
Good evening, Mr. Ray.
How are you doing?
Good, and yourself?
I'm doing well. Thank you very much.
Not at all.
Thank you. William.
Yes, sir. I'm here.
Good evening, William. How are you doing?
Good, and yourself?
Doing well. Thank you very much. And Salvador. Might have stepped in. Oh, yeah, you're there. Good evening. How you doing?
Good, good. How you doing?
I'm doing well. Thank you very much. And Raymond, welcome again. All right, you're there. Okay, so we'll wait a few more minutes before everyone else comes in. But you should have got a message from me asking you to sign up for a GED account. Did everybody get that?
Yes.
Yes.
All right. Please do so if you haven't done so already. If you don't already have one, please go ahead and try to get that done as soon as possible. The school is requesting that everyone has an account. And so you might have got another teacher ask you if you're in another class. But yeah, please do that. Go ahead and make sure you've registered. It's a very quick process. You just sign up, you just put your name in, a password, and done. And that will be the same account that you will use to do the practice test and also to sign up for your actual test. All right, let me get Gennaro.
Hello, Mr. Ray.
Good day, Gennaro. How you doing?
I'm good. How you doing, sir?
I'm doing well, thank you. It's good to have you today. And
Good to be back.
all right, Latavia. Welcome, Latavia.
Thank you.
All right, so I'm gonna go ahead and start to share the screen. Now, you guys have almost caught up the other class, so I kind of get mixed up to where you are, to where they are. Before you guys were like 2 weeks behind them. Now you're like a day or two behind them. So I'm getting mixed up with who's where because you guys are basically on the same lesson now. They're just finishing this one and you guys are like starting it. So you guys are moving quite quickly. Welcome, Dorcas. See that you've joined us as well. No, she can't hear me yet. All right, so first of all, any questions from any of the homework or anything that we've done previously?
Yes, Mr. Ray, on page 59 in the workbook, can you go over number 6 and number 9 for me?
Okay, 59 in the workbook.
Number 6 and 9.
Okay, number 6 and then number 9. All right.
Thank you.
You're welcome. Okay, so once again, if you didn't hear it, this is number 6 and number 9 in the workbook. Okay, let me just get my pen. Okay, number 6 says the museum admission fee, that one, right?
Yes.
Okay, so the museum admission fee for a child is $4 more than 1/2 the admission fee for an adult. Which expression describes the amount paid for 12 children and 4 adults to visit the museum? All right, so first of all, let's go ahead and write out what this expression is. So it says the museum admission fee for a child. So basically, this one is a little bit challenging compared to what we've done. But basically what you just wanted to note is that the child, oops, that's a chid. The child Just gonna mute everyone real fast. All right, so the admission fee for a child is going to be, this is kind of an equation. This is kind of, this one should technically be in lesson 2. But anyway, I haven't got to equations yet, but basically you're saying the child and then is. The is we represent with an equal sign. So you could replace the child now with C. If you wanted to, you could say C equals to represent the child. But like I said, this one is kind of misplaced. In my class this morning, we realized number 22 was also misplaced. They should actually be in lesson 2 rather than lesson 1, because we haven't got to equations yet. And clearly number 6 is an equation style question. But so far, you have C equals to $4 more. So your child ticket is going to be $4 more. So 4 plus 1/2 the admission fee for an adult. And so you could put A for an adult. So which expression describes the amount paid for 12 children and 4 adults? All right, so first of all, you need to see how much would it be for 12 children. And let me just get Marisol. So you're gonna, if this is one child, right? That represents one child. What would you have to do? I forgot who just came in. Was it Marisol?
Ray.
Okay, yes, it was Marisol. Welcome, Marisol.
Thank you, Mr. Ray.
You're welcome. And Marisol, we are on number 6 on page 59 on the workbook. I got a few people coming. And welcome, Susanna, if you can hear me.
Hi.
Yes, good evening. And Susanna, we are on page 59, number 6 in the workbook.
Thank you.
You're welcome. All right, so where was I? So we have one child is represented by this. Is everybody clear with what I've done so far?
Yes.
All right,
Yes.
so,
Yes, sir.
all right, so that's for one child. So what would I do if it was 12 children? Well, I'm gonna basically multiply it. For 12 children, this has a lot of elements that we haven't done yet. I'm gonna do it anyway, but some of this stuff I haven't taught yet, so that's where you're having the troubles. But we're gonna have 12 times 4 plus half A. Does that make sense? At least what we're doing?
Yes.
All right, so I don't think I've taught you how to distribute yet. I don't recall showing you how to, but you would have to distribute this into the expression. So if you was to do that, that'd be 12 times 4 and 12 times a half. So that means 12 child tickets will cost 12 times 4 is 48, and 12 times a half is 6, or half of 12 is 6. Okay, hold on real fast. I just gotta let in Maria. And welcome, Maria. Maria, can you hear me? All right, not yet. So right now, that's 12. Hello?
Hear you.
Welcome, Maria. We are on page 59, number 6 in the workbook.
Okay.
All right, so 12 children tickets. So 12 children's tickets will cost 48 plus 6A, which means once you find out what the adult tickets are, then you can just simply add them. So we have 48 plus 6A representing 12 child tickets. And how many adult tickets are we going to have? According to the question.
4.
4.
4 and 4 adult tickets. Now, because we don't know what the adult tickets are, we could represent that with 4A. Right, so 12 children tickets and 4 adult tickets. So 12 children tickets are 48 plus 6A, and 4 adults tickets is just 4A. So then once we do that, we could collect the like terms, and we have 48 plus 6A plus 4A would be how many A's altogether?
10.
8.
10.
And
So that means our answer would be, well, they wrote it the other way around, so our answer would be 10A plus 48, which would be, which one would that be?
C.
C. So the answer there would be C. So like I said, this has a little bit of elements that we haven't done yet, but you know, we're working our way there. And at least you could see it in advance. If you understood it, great. If not, then you'll learn more about how to do this as we go on. All right, any other, did
Thank
that
you.
help? Was that, did it,
Yes,
Yes.
yes,
okay,
it did.
did you
Thank you.
understand it?
I'll go through it again. Thank you.
Okay, no problem.
Appreciate it.
But I'll go through it one more time as well. So once again, we determined that one child ticket based off of writing an expression was 4 more, right? If I say I have $4 more than you and you had $6, then how much money would I have?
10.
10, right? 4 plus
Mhm.
whatever it
Oh,
is.
yeah.
So in this case, we don't know what it is, but we know it's half of whatever the adult ticket would be. And so we say 4 plus half A. So that represents one child ticket. But they want 12 children tickets. So that means we're going to have to multiply the amount by 12. So for instance, if a child ticket costs $2 and I got 12 of those tickets, how much money would I spend?
24.
24, right? 12 times 2 is 24. So that means I'm going to say 12 times whatever the child ticket is represented with, which is 12 times this expression. Then using some algebra skills, which we'll review some more today, I believe, because I think I might have touched it with you, we distribute the 12 into the quantity. So we say 12 times 4 is 48, and 12 times a half is 6A. So now that represents 12 children tickets. But it says that you want to also know how much 4 adult tickets are. So basically, I should have wrote this in a different color. Maybe it might have made it a little bit easier. But basically, the statement is that you're going to have 12 children tickets and 4 adult tickets. We just saw that the 12 children tickets is 48 plus 6A. And 4 adult tickets, because I don't know the cost of the adult tickets, I could represent it as 4A. And then all I need to do now is simply add those together. The children's tickets, what is with this thing? I have something blocking my screen. Sorry. Okay, here we go. So we have the 48 plus 6A, which represents the 12 children tickets, plus the 4A, which represents the 4 adult tickets. The like terms are simply the A's. So 6A plus 4A gives us 48 plus 10A. Now, what that expression would do is once I find out what the adult tickets are, it will give me the total price for everyone. And so what you've seen here is that we now have a simplified expression that allows me to know what the total amount of tickets are right away. So let's say we were planning like some field trip, maybe it's a church group or some scout group or something, and they're planning to go to a museum, and you're in charge of that, and you're like, man, I didn't even know how much the tickets cost. All I remember is that it's $4 more. Well, you could come up now with that expression, and the moment you find the price of the adult tickets, you know the total price of everyone's tickets. And so let's say the adult tickets was $5, then you say 10 times 5 is 50, 50 plus 48 is 98, so it will cost $98 for the 12 children's tickets and the 4 adult tickets. And that's the beauty of algebra, allows us to make calculations really quickly. All right, hopefully this second explanation helps to reinforce the concepts right there. Any other questions with number 6?
No, sir.
All right,
I got it now.
anyone else? Any questions from anything in here? Just to be forthwith, some of these questions you just might not know how to do yet, but it's always good to try them. And we do have a good bit to cover, so it's always good to push yourself. So any other questions with any other of the problems in this section?
I tried number 9 on my own, and I got A for the answer, but I'm not certain if it's correct or not.
Oh, right, you wanted me to do number 9 as well, right?
Yes, please. Thank you.
Okay, so number 9 says A school sold adult tickets and children's tickets. So number one, sometimes it helps to write out what the expression is. You have adult tickets plus children's tickets, right? And you could write it out completely, but I'm just looking at time. So adult plus children. To a football game, the number of children's tickets sold was 56 more than 1/3 the number of adult tickets. Which expression describes the number of children's tickets sold? All right, so in order to write out that expression, we don't know how many adult tickets are, and we're using the adult tickets as the base because of the second sentence. The second sentence says the number of children's tickets, which means if I want to get an expression or a value for the children, then it's followed in the second sentence. Now, just to recap, we went over how to do expressions, right? We were doing 4 times X and all that stuff. We did that already, right? Say that again, William.
I think we did.
Yeah, in the student book on page, I just want to make sure I'm not jumping the gun. Like I tell you guys, because you guys are like right next to the other class, I'm getting mixed up with who did what now. I'm gonna have to write it down. Before, you guys were so far apart that I knew who did what. Did we do on page 50 in the student book? Did we go over those things on my PowerPoint? 4 more than a number, 5 less than a number. We did that, right?
Yes, we did that on Tuesday.
Okay, perfect. I just want to make sure no one is completely lost. All right, so what we have is adult plus children. And so the second sentence tells us how to set up the children. And we're using the same terminologies in that box. So you can open up your page to 50. If you copied it from the PowerPoint, you can look in your notes, but we're going to use those terminologies to help us. So for the children, it says the number of children's tickets sold was what?
56.
56 what?
More.
More. So more is plus, right?
Plus
Plus what?
1/3.
1/3 of 1/3 what?
Adult.
Adult tickets.
Adult tickets.
Now, do we know how much the adult tickets cost?
No.
So what can we write instead of the price of the adult tickets?
A.
A, right? We can use A to represent adults. And you can see that in the answer selection, that it has to be A. Now, do we know the price of the adult tickets? Because remember, this expression only represents children. The children's tickets can basically be represented as 56 plus 1/3 A. But now we need to write an expression for the adults. And what can we use for adults?
A.
Just A, right?
Yeah,
So
A.
now we have our expression. We have A, which is the adult tickets, plus the expression or quantity 56 plus 1/3 A, which represents the children. Does that make sense?
Mm,
A little bit.
Right, so remember, we used our understanding from what we did on Tuesday. We wrote out what the children represents. According to the second sentence, the children is the number of children's tickets sold was 56 more, which is plus, than 1/3 the price of the adult tickets,
okay.
right? But that expression only represents who?
Children.
Children.
Children. In order to find the total price, I need to add that to what? Or actually, you don't even have to do that. This one, I didn't read the whole question. It only asks you which expression describes the number of children's tickets sold. So you don't need the total. The other question, you needed the total. For this one, they only want the children. So what's your answer? We can rewrite the order.
1/3 plus 56.
Right, 1/3 A plus 56. Now I can see that this might throw you guys off, so let me remind you about fractions. Remember, the A represents a number, and when a fraction is written next to the letter, remember that means multiplication.
B.
Because A represents a number, how do you write any number as a fraction?
Decimal.
No, that's a decimal is different than a fraction. Remember, if we have the number 3, to write it as a fraction, we just write it as 3 over
1.
1
Oh, okay.
over 1.
So in order to write A as a fraction, it's the same as A over 1,
Okay.
right? But when we multiply fractions, we multiply the numerator with numerator, denominator with denominator, basically straight across. So 1 times A is A, and 3 times 1 is 3. So we have A over 3 plus
Yeah.
56.
Oh, it's B.
So yeah, the answer there would be B. Let's just practice that really fast. Let's say I have, I didn't mean to put equals, I meant to put number 1. So number 1, let's say I had a half of, that looks weird. Let's say we had 1/2 times B. Number 2, let's say we had 1/4 times E. Let's say we had number 3, 3/4 times A. What would this one equal to if I was to simplify it into one term, one number? Well,
B divided by 2.
there we go. That's the answer. How about the second one?
E divided by 4.
E over 4. And how about this last one? Don't think too hard.
3 divided by A.
Not 3 divided by A. What did we do for all the other ones? Where did we write the letter?
A divided by
A, I'm sorry.
3 times 8. 3A and 4. Over and 4.
All right, there we go. 3 over 4. Remember, it's based off of what we learned in Unit 1. Everything is based off of Unit 1. So basically, you're just multiplying the numerator with numerator. Now, with the first two, B times 1 is just B, because 1 times any number is itself. So you don't have to write the 1. You could write the 1 if you wanted. You could have 1B and 1E, but kind of looks funny. Just like I said before, you don't, at least I think I said it to you guys. If somebody said, let's say you only have 1 car, and someone said, how many cars do you have? The average person is not going to say, I have 1 car. They might just say, I have a car, you know, or you might just say, look, there's a car outside, right? You might not say, look, there's 1 car outside. The average person is going to say, look, a car, or look, a mountain lion, right? I doubt you will say, look, there's 1 mountain lion, right? On average, when we see one thing, we just say there's something, right? It's the same in algebra. We don't have to write the ones. So technically, for number 1, it's 1B over 2. For number 2 is 1E over 4. And then clearly, number 3 would be 3A over 4. Does that make sense?
Yes.
Yes.
Right. So
It
that
does.
that actually pops up pretty often, where you might work it out to be like a half x plus 3, but then you look in the answers and it's x over 2 plus 3. And that throws off a lot of people. People are really confused about that. So let's just do that one. And welcome, George. I think you should
Yeah,
be
Miss
connected.
Ali,
Yeah,
just a bit
welcome.
late. Yeah.
Yeah, it happens. You're normally one of the first people here, so it was shocking.
Wow, wow. Today I don't know what really go wrong with me.
Well, it's good to have you.
Thank you.
All right, so let's try just a few more there. So let's say I had 2/3 times b squared. Let's say number 5, I have 1/2 times xy. And number 6, let's say I had 5/7 times x. Okay, what would the first, or not the first, rather, what would number 4 be if I wanted to write it as one fraction?
2B squared
2b, yep, 2b squared
divided by 3.
divided by 3. How about number 5?
XY divided by 2.
There we go, xy divided by 2. And the last one,
5x divided by 7.
5x divided by 7. Okay, so those are all equivalent. So keep that in mind. For a lot of people, they would have got down to that answer if they got it right. And they're like 1/3 A plus 56, but I don't know which one that represents, right? But now you know. And you can see there's a little trick there. They have 1/3 A subtract 56. And do you know what a lot of students would do? Well, maybe I messed up with the plus sign. And they'll change the plus sign to a subtraction sign because they may not know the equivalence between 1/3 A and A over 3. It basically means the same thing. Remember, 1/3 of something basically means that you're dividing it by 3, right? If I, let me just go over one. So this is back to what we just did. If I have 1/3 A, let's say A was $9. Where's my erase? Right, let's say my A was $9. Well, what's 1/3 of 9?
3.
3. That's no different than saying 9 divided by 3, right? What's 9 divided by 3?
3.
3. It's the same thing. If I have 1/4 times 16, or 1/4 of 16, what's 1/4 of 16?
4.
4.
And what's 16 divided by 4?
4.
4.
4. It's just different ways to write it. So if you see a fraction like half x and then it's rewritten in the answer key as x over 2, then don't freak out. You know what exactly what to do. It's just to rewrite it in its other format. All right, so once again, the answer for number 9 would have been B. Okay, any other questions from the homework? Some of them is entering into stuff that we're learning today, but that's fine. Any other questions from this section? If not, we're going to do similar problems in the student book. We can also come back to questions from here because it's good to practice this, as you will have to do this pretty soon, solving equations. All right, so if there's no questions from here, from that section, just going to mute everyone. All right, so ask one more time, just in case. Were there any other questions from page 58 to page 61?
No, Mr. Ray, thank you.
All right.
Not me.
Did I hear yes, please, or did I just hear make that up? Okay, so if not, we're going to go back to the student book real fast to practice a few more things. And very similar. I think we did number 1 already. Did we do number 1 on Tuesday?
Yes.
Okay, we did number 1.
Hi, Mr. Ray.
Good evening, Dina.
Hey, sorry, I thought we didn't have any class today. For some reason my calendar didn't put it down.
Oh yeah, well, you know what's crazy? When I went to start the class, the Zoom thing wasn't even there. I had to like reset everything.
Oh, okay. Yeah, so as of today, my whole calendar thing doesn't even have you on there.
Oh wow.
So it only shows that Tuesday, that was our last class.
Yeah, I'm not sure what happened. On my side, it still said that I end in December, but it just would not show up. So I had to kind of reset everything. So maybe there's some type of glitch happening all over the place. But computers
Okay.
are known to do that. Sometimes you can have a glitch and it like resets something on you.
Got it. Okay. All right. But I'm here.
Okay. We just finished looking at the student workbook, and now we're moving on to we just finished working in the workbook, and now we're moving on to the student book. So on the student book, we are on page 51.
Okay.
The pages almost correlate there. And I believe we did number 2 and number 3 and number 2 and 3 on Tuesday, right?
No, you said no on number 2.
I said no on number 2?
Yeah, you said do from 1 to 10, but not number 2. Because I think number 2 was off the topic, something like that.
I think that was for the homework.
Oh, that was for the homework in the workbook.
Yeah.
Yeah, so we're back in the student book now.
Okay.
Yeah, but did you have any questions from the homework?
No. I think I got it. Pretty
Okay,
clear right now.
perfect. All right, so no, what I can't remember, I'm pretty sure we did number 2 in class on Tuesday. Does anyone remember doing that? Okay, I didn't. Yeah, we did this in class.
We did. Yes, we did.
Yeah, we did number 2 and number 3. And I want to say we did because like I said, I'm going to say it again. You guys have literally caught up the other class. You started 2 weeks after them, and you were literally 2 weeks behind them. But now you're literally like, you're right on their heels. We literally just finished this today with the other class. And so I'm like, man, I'm mixing up who did what because we're on the same page. So did we do number 6 on Tuesday?
No, we didn't do that.
Okay, perfect. All right, so we're going to do now number 4 and number 5. Now, number 5 is going to take some thinking, so be ready for that. Let's go ahead and try number 4. Go ahead, read it, and see if you can get it. You can read along with me. This one's 2-step, so you got to write and simplify. But before we do that, let me review something real fast, and that's distribution. So the distribution property, I briefly went over it when I went over the homework, but I just need to make sure everybody remembers. Okay, so you see this in your book. Now the distribution property is remember I said whenever you see parentheses in algebra, it represents what operation if it's a number written right next to it?
I think it's multiplication.
Multiplication, right?
Yeah.
And that's only when the number is written right next to it. If there's an addition sign separating it, then it's not multiplication. So if I had 4x plus 5x plus 7, that is not multiplication because that plus sign. But when it's just simply written right next to it, it is multiplication. Remember, we don't use the cross product anymore because that confuses people with x. So we will either use the dot product, so we say 4 times 3, or we'll say 4 times 3. Okay, so when you see that 4x times this quantity, we call this a quantity. Another name for it, sometimes you might hear group. And for both of them, we use parentheses. So parentheses, or even brackets, parentheses, and sometimes brackets. So parentheses looks like this, and brackets look like that. So sometimes both of them are used. But whenever you hear the word quantity, it's talking about a group of terms that are being multiplied or divided by another term or number. And so they're kind of sharing the same operation that's on the outside. So because I am multiplying the quantity by 4x, everything inside of the quantity has to be multiplied by 4x. You could think of it as a household. If a father of a household or mother of a household buys pizza for everyone, does somebody do they skip someone? Does someone not get pizza? Like you don't get pizza because you're not really part of the household. Does that happen? Hopefully not. Hopefully everyone in the household gets the pizza. It's a pizza party tonight and everyone in the household gets the pizza. It's the same thing here. In this quantity, everyone, every item, every term will be multiplied by the term on the outside. We call that the distribution property. And if you're wondering how to spell that, it's the distribution, because you're distributing the term inside. So that's called the distribution property. So you might even see that pop up on a question. You might say, use the distribution property. All right, so when you do the distribution property, excuse me, the key is to multiply the number with number, and then number 2, variable with variable. Now, when you multiply the variables together, you have to remember the laws of exponents. Oops. That's the laws of exponents. All right, so we're going to multiply the 4x right in. So we're going to have 4x times 5x and 4x times the 7. So remember, though, when we multiply in, we're following those two steps. So if we multiply those numbers together in the first one, what's 4 times the 5 going to give us?
20.
20. And what is x times, what in the world? What will the x times x give us?
S square.
X squared. Well done. That would be x squared
Oh, wow.
using the laws of exponents. All right, and then we have to multiply the second term. So 4x times 7. So what's 4 times 7?
28.
28x.
28x. That's correct, because there's no, technically there's an x there, but it's really x to the power of 0, and x to the power of 0 is 1, and 7 times 1 is 7, so there's no need to write it. So basically, the x just comes over by itself. Now, once you multiply out parentheses, basically disappear, so they're done. And what's left is subtract 2x. However, what you'll notice is these are like terms. And what do we do with like terms?
Add it.
Right, we can add or subtract them. And in this case, we're subtracting. So if I have 28 xylophones and I'm taking away 2 xylophones, how many would I be left with?
26.
26. And so I have 26x. And that will be the answer. So we call that,
Mr. Ray, I don't get it clear. Just
which part?
the where we are now 20x squared plus 20, which is 28 plus 28x minus 2x. How do I arrive at the 20x plus 26x?
Because we're combining these two together, the like terms,
Okay, okay,
right? 28x subtract 2x is 26x.
okay, okay.
All right, one little change here. I said distribution property. Must be I'm tired. It's the distributive property. I mean, very close to synonyms, but it's called the distributive property, not distribution property. So, you know, just fix that. All right, any questions there with the distributive property, what we just did? All right, let's try some. Was that a question or did I just? All right. Okay, I'm about to clear all this information. Does anyone else need it?
No, I got it.
No, I'm got it.
I got
Alright.
it.
Perfect. Okay, so let's try some more, and I'll throw in a variety of stuff, of course. And let me just let Norma in. All right, so let's try. I'll make them pretty similar, but of course, increasingly challenging. Number one, to try, let's say we have now negative 3x times 2x subtract 5 minus x. And then number two, let's say we have, I'm going to throw it up an ante. Let's say we have 4x squared times negative 3x plus 4 minus 6x squared. And then number three, if I could fit that in there, let's say I had 3xy times 5xy subtract, let's throw in a negative there, negative 3xy times that 5xy subtract 2, and then add that to 4x squared y squared. There you go. This look nice. All right, so try them out. It might be hard to send in your answers, but you guys are creative. So if you get your answer in, if you don't have too much of a struggle with it, go ahead, send your answer. You can send it privately if you don't want anyone else to see it. Or you can send it to everyone if you don't really care. But yeah, try them out, send in your answers, and I will try my best to see if I understand how they're coming in. Because everyone tries their own different way of communicating that to me.
Mr. Ray,
Yes.
I think I'm done with it, but I don't know how to start typing it on the computer.
Okay. Remember, you can use the little caret sign. So let's just say you had 3x squared. You could say 3x and then that little symbol and then 2. That means 3x squared.
Oh, okay. Let me see.
It's if you're on a laptop or even a regular one, it's where the 6 is on the top. So where the 6 is on like above QWERTY or QWERTY rather.
Oh, okay. Oh,
Yeah.
okay. I see. 3x squared.
How do we send
What
it?
about if it's cubic root?
Then you just do the same thing. You just put a x that's
Same
the
method?
and then 3. So that means x cubed.
Okay. Okay.
And if it's x to the power 4, you just do x caret and then 4. So that's a generally accepted rule. Like back in the day, that's how you had to type it in the calculators. And in some programs on your computer, that's what you have to use to do it as well.
Mr. Ray,
Yes.
I'm signing off now.
Oh, you got to go? Okay.
Yes, I'll send you my answers over the weekend.
Okay. Just try to look. I'm going to try to, but try to see if you can look at less than 2 on equations. We may or may not get there, but
Okay.
all right. But we are kind of
All right.
covering some, look up order of operations as well, if you can, order of
Yes.
operations. Yes. And factoring.
Okay. Thank you, sir. Have a
You're
good
welcome.
evening.
You as well.
Okay. Bye-bye.
Bye.
Six.
All right, let's see. Okay, yes, that's correct, Dorcas.
Mr. How can one send his or her answer using the computer? Because I have the chat, the share screen, records, and reaction. But I don't
No,
know.
you could try to type it in the chat. You can't share the screen right now.
Okay,
Yeah, I don't give that option.
okay, all right. How can I send the result to you?
Just type it in. Just type in what you have. So for instance, let's say your answer was 5x. You would say 5 in the chat, x. You
Yeah, where should I type it? Because the way I have the chat, the share screen, records, and reaction, I don't know the real ones that I should type it.
You don't see the chat option. It should say CHT. If not, try. Do you see 3 dots on your menu?
3 dot, 3 dot, 3 dot.
Let me send something and see if it lights up on your side.
Where it
Send
says
it.
more.
Yeah, you should see more or something. It could look
Yeah.
different based off if you have a computer
It
or
says more with 3 dots.
yeah, more and 3 dots.
Wow, where is it?
I'm sending you a message. It should light up on your taskbar. Did you see it?
No, sir.
So do you see the black taskbar that has all the choices?
I'm on computer. I've used the screen where I just connect with internet.
Right, but on the Zoom screen, you should see like a black menu. It's different than my side because I'm the presenter, but I forget what it looks like on your side. But it's still pretty similar. You should see like a black menu either on the top or the bottom. I doubt you moved it to the side, so it's either on the top or the bottom. But if you hover, like take your mouse and hover at the top or hover at the bottom, it should just appear. And you should see a choice selection.
Wow, wow, wow.
Mr. Ray, the third one, I don't know how to type in the answer for the third one. Is it
Oh,
the
you just
same
do-
method?
Let's say, more than likely, I'm assuming it's when you get that second one. So let's say you had x squared, y squared, you say x squared, y squared.
Okay, x squared, y squared. Okay, okay,
Right.
okay.
I didn't mean to erase that.
Can I send this thing?
Did you find it, George?
No, I've not seen it. I'm
So
since,
what do you see?
since I'm using the computer. Yeah, the heading I have Zoom meeting, then view option. Are you viewing that is raydark.com? Yeah, at the top of the screen. Yeah.
So do you see me still?
Say that again.
Can you see me?
I'm seeing you
Can you see my screen with all the work and stuff?
behind you.
Okay. And then can you move your mouse down to the bottom of the screen and just leave it there?
Okay.
Like, does something pop up?
Okay. Yeah, I saw that. Where is it there? I don't know. Some black.
Right, the black, you should see
Yeah.
like a black strip.
Yeah, it came out better. I'm not seeing it any longer.
Right, so just, that's how it comes up. When you hover the mouse over it, it pops up.
Okay, okay. So when I see it, I click on it.
Well, okay, you should tell me what you see on your panel.
Oh, wow. Just those questions that you put on the board. Wow. What is going on here? Shit. Okay.
All right, Dorcas, that's correct for your second one. And
What about the third one?
I'm looking at it now because I didn't write it out, so I'm doing it in my head. And the third one is correct as well. So well done, Dorcas. You've been practicing.
Thank you.
You're welcome. All right, I haven't got that many answers in, so how's it going for everyone? Everybody there? This Thursday seems to be a sleepy night.
I'm sorry, I'm kind of confused on it, so I'm waiting for
Yeah, me
Yeah,
too.
it
I
to
was
start it so I can look at it.
How many people waited?
I was waiting for you, Mr. Ray. I've been waiting for
solved
you.
them, but I'm just waiting to see how it turns out.
So nobody wants to send in what they got? No one else,
No.
rather?
Mm.
Okay, let's start going over this. I was like, man, these guys are working hard.
No. I was waiting for you, Mr. Ray.
So is it working hard or hardly working?
Hardly working, Mr. Ray.
All right, let's go ahead and okay, wait, hold on. I got another answer pop in. Okay, Veronica, I'm believing that's right. You just forgot out that 2. So I'm pretty sure you got it right. So well done, Veronica, as well. All right, let's go over this. So we're going to use the distributive property to do this. And I'm going to mute everyone real fast. And if you have a question, of course, just unmute yourself to ask. All right, so first things first, we want to distribute the negative 3x. Now remember, the sign goes with it. The sign belongs to that number. We practiced that in integers back in like lesson 3 in unit 1. So we're going to multiply this in, negative 3x times the 2x. And if we do that, we get negative 6x squared. Right, does that make sense? Number with number, variable with variable. Negative 3 times 2 is negative 6, and x times x is x squared. Right, but then, because that's a quantity, everything inside of the quantity has to be multiplied by the term on the outside. So we say negative 3x times negative 5. But notice that's a negative times a negative, and who remembers what do we do when that happens?
Positive.
It becomes
It becomes
positive.
positive.
It becomes positive, right? When you multiply. So -3 times -5 becomes positive 15 when you multiply
15
number with
X.
number. And then, as Dorcas just said, there's an x still there. So -6x squared plus 15x. And very close, Veronica, like I said, with your answer. All right, so any questions with number 1? Anyone else get that correct and was just a bit afraid to say it?
So,
I have.
Got something different.
A little
Mr. Ray,
different?
I got mine correct.
Okay, well done.
What about the -x, Mr. Ray?
Oh, mercy, thank you. Forgot about that -x minus x. And that's gonna give us the 15x subtract x. It's gonna give us that 14, positive 14x. So my bad. Thank you, Salvador. I didn't even notice that I left it out.
Wow.
It won't be positive 3 or positive x.
Positive x, you said?
Yeah, because you know how it's -3x and then minus x. It won't be positive.
Oh no, because this minus is outside of the quantity, so you're not multiplying it.
Oh, it stays the same.
Yeah, it's outside.
You know what, Mr. Ray?
Go ahead, Jacob.
Oh, okay. I took, because I still went and I did, I messed up my signs a little bit,
Right.
but I still went. For instance, right here, I still did 6x squared plus 15x, so it would have given me, I added that up, and then I subtracted the x, so I got just, yeah.
So a slight error.
Not a pretty big one.
So what was your final answer?
9.
Oh, okay. So yeah, you combined everything. But yeah, because
Yeah,
of
I
that
did
x,
everything.
because of the x squared, you can't add it on,
Got you.
right? Because it's not a like term.
Okay.
Yeah, be careful of that because that's a common
Yeah.
mistake that people make. But
Yeah, that's pretty bad.
because of that 2 there, it means that it's not the same as the other x's. So yeah, thanks Salvador for reminding me about that. So remember, once we multiply out the parentheses, they disappear. And the subtract x, I just didn't see it just now. But yeah, so that subtract x is now there. That subtract x does not get affected by the -3 because it's not being multiplied by the -3. So it stays a -x. And remember, -x is the same as saying a car, right? Or $1, right? We seldom say $1. We might just say it costs $1, right? So just the x is needed. And because of that, we know it represents 1x. So 15 subtract 15x subtract 1x will give us 14x.
Messed up with all these.
Okay, so that takes us now to the second one. And similar thing, remember, we're going to distribute into the parentheses because when the parentheses is written next to a term, a number, a variable, it represents multiplication as long as there's no plus sign or subtraction sign separating the term and the quantity. So this term is written right next to the quantity. So we are going to distribute this into the parentheses. And when we do that, number with number, variable with variable. We'll try to write this smaller. So what would 4x squared times -3x equal?
12x cubed.
Minus negative
X
12.
cubic root.
Okay, I heard a few answers, but I was able to pick out the correct answer. -12, right? Number with number. 4 times -3 is -12. And then variable with variable. So x squared times x will give us x cubed. Remember, the laws of exponents is what we do when we multiply the variables. And technically, there's a 1 here. We don't write it. So when we multiply bases that are the same, we add the exponents. That's less than 3 in this unit. I think it's less than 3. Just trying to check. Less than 3 and less than 4 in the unit. We talked about exponents. Remember we skipped and then we came back. So we are adding the powers. All right, so that's the first one. And then we need to multiply to the second. They're both positive, so you shouldn't have to worry about what sign. Remember, number with number, so 4x squared times positive 4 will give us what?
16.
16.
Right, positive 16, and then there's no x there, so we bring the x squared with it. Right, and then the last part, now that we've multiplied out the parentheses, there's still a subtract 6x squared.
Minus
And
10x squared.
not minus 10x squared,
Minus 10.
not
Negative
minus,
5x to the
Plus,
cubic.
plus 10x squared.
plus, right? So that would be negative 12x cubed. The 16x squared, subtract the 6x squared would give us positive or plus 10x squared. And that will be the answer there.
I got it.
I had
All
a
right.
question though.
I got
Yes.
Why for the 4x squared times minus negative 3x, why wouldn't it be a positive?
Because of this negative right here. Remember, negative times a positive is a negative.
Negative.
So remember, these are the rules when we did integers, a positive times a positive, and it's the same for multiplication or division. So if I multiply a positive number by a positive number, or I divide a positive number by a positive number, the answer is always positive. If I multiply or divide a positive and a negative, the answer is always negative. If I multiply or divide a negative and a positive, the answer is always negative. And if I multiply or divide two negative numbers, the answer will be positive.
Okay.
So we had a positive 4 times a negative 3 would mean my answer would be negative 12.
Yeah, 12x 3x cubed plus 16.
Okay, any other questions there? All right.
Mr. Ray,
Yes.
I got the first two right, but only the first part.
Oh, yeah. So just work on that second part. That's actually a mistake, and that's a common mistake. That's why I draw those lines, because the most common mistake all over the world, I mean, every single country, is that people forget to multiply the second one correctly. So that's why I draw those lines in to try to help you guys to remember to multiply the second one and remember number with number, variable with variable. All right, let's try the third one if there's no other questions. Same concept. We're going to take the term on the outside, negative 3xy, and we're going to multiply it into the quantity, which is called the distributive property, because we are distributing it to everyone, right? Distribute means to give out. So we're distributing it inside of the quantity. All right, so number with number. So what's negative 3 times 5?
15, negative
15.
Right, so we have negative 15, and then xy times xy would give
Square. X squared.
Square.
x squared and
Oh.
X squared and Y squared.
x squared and y squared. Correct, right? X times x will give us x squared, and y times y gives us y squared. Okay, so that's the first term. Now we need to multiply into the second term. Right, if we do that, negative times a negative is a
Positive.
positive, and then 3 times 2 is
6
6,
x,
and
y.
then we have the x and the y follow. Now the parentheses have disappeared. We have multiplied them out, and so we're left now with plus 4x squared y squared.
Mr. Ray, you know that the bot is small. I will not even see them completely.
Say that one more time.
Actually, what you put on the bot is small. You just up. I will not just get
Yeah,
them.
I didn't have much room, so I had to write it smaller.
Okay.
Yeah. All right, any other questions about how to get that line? Did everyone understand that?
Yeah.
Okay, we're not done. One more step now.
Okay.
We have, what are my like terms here?
The 15, minus negative 15, and the positive 4.
Right, so the negative 15. Yeah, that's correct.
19.
Well, be careful. The negative belongs to the 15, but the 4 has a positive. I just heard it. So if you remember integers, you have a few ways that you could try to remember how to combine those. But negative 15 and positive 4 will give us negative 11.
Negative 11.
Right. Remember, you could say I owe $15 and I have $4 and I pay it off. How much money I have now? So negative 11, because they are like terms, the rest of the term comes down with it. So x squared, y squared.
Mm-hmm.
And then
Plus 6y.
plus 6xy. That's correct. And that would be the final answer.
Mr. Ray.
Yes.
Okay, let's go to the point. Minus 15, then minus 15xy minus 6xy.
Plus 6xy.
Then plus 4x squared and yx squared.
Right.
Okay, then the test step, I don't get it well because.
Well, because we're looking at like terms, and the like terms are negative 15x squared y squared and positive 4x squared y squared.
Okay, for the first one, the first line, negative 15, I got those one completely good. But the last stage, that is why I have that doubt, because we have, I think that since you have minus 15 x squared, xy, minus, it could be minus 6.
No, that's a plus 6. And
Yeah,
that plus 6 is not the same like term because it only has an x and a y. It doesn't have x squared, y squared. So the terms are not the same.
Okay.
Right? They are different. X is different than x squared. Y is different than y squared. So they cannot be the same term.
So what could be the answer? Minus 21.
No, minus 11.
Okay.
Right? Because negative 15 plus 4 is negative 11.
Okay, 11xy.
Negative 11 x squared, y squared.
Okay.
All right.
Okay, thank you.
You're welcome. And I'm just muting everyone real fast. Okay. Any other questions about regarding 1, 2, 3?
Negative, Mr. Ray. Mr. Ray, do you have a like a worksheet or something on this? I think
yeah, I was gonna send you guys one. I'm just gonna if I stop sharing, it will disappear. Okay, no problem, Sergio. So does everyone have this? If you don't, Sergio, you might want to take a picture of it with your phone or something, or a screenshot if you know how to do that. But in order for, I want to send a worksheet now so I don't forget it. But I want to send a worksheet on this. And in order to do that, I actually need to come out of here. But if I do that, it's going to disappear. And when I annotate, it doesn't save it. So once I close this out, it's gone forever. So does everyone have this copy or taken a picture of it or screenshot it?
I have, sir.
All right. Has anyone not? Let me ask it that way. Has anyone not been able to?
No, let me just take a picture of it.
Yes. So I'm gonna count down from 10, and by the time I get to 0, if I don't get any objections, I'm going to clear it, and it'll be gone. So 10, 9, 8, 7, 6.
I'm done. I've
3,
taken.
2,
No, slow down now.
1. All right, I'm at 0. T minus 0 seconds. I'm about to close it. I'm about to close it. The only reason I keep saying this, from experience, I was saying I'm about to close it, and then when I do it, someone's like, "No, Mr. Ray," and I'm like, "Man, I counted down and stuff." So, has everybody got it?
Yes, sir.
But once I do it, it's gone. I can't bring it back. It's gone.
Go ahead, Mr. Ray. Mr. Ray, and then you're gonna send us a worksheet, huh?
Yes, I need to do it now because I might forget because there's a few other worksheets I'm sending, and this is not one of them. So I need to go get it now.
Okay.
Yeah. So I'm stopping now. All right. So I'm gonna send it right now into the Remind group, and so just bear with me real fast. It's because I have some other worksheets I'm sending you, and this isn't it. So I really want to make sure it does have some distribution, but it's not as detailed. So I just need to find one that has all of it. Okay. All right, so I'm gonna just do that a little bit later. The only thing I can find that has a combination of the two is you gotta pay for it. I'm not about to pay for that, and I don't think I have one readily available. So I'll just have to do that later, but because I have it up, I should remember it. Let me just check one more time. All right, yeah, I'm gonna have to just do that a little bit later. All right, so we're gonna move on from here. I will try to have that worksheet to you guys. I couldn't find one that actually, without having to pay, that was similar to what I just did. And I don't think I have one that's readily available, like I said. I might have one somewhere stashed on my computer, but I was just trying to see if, yeah, this is too complicated. All right, yeah, I'll try to do that later for you guys. But we're gonna move on now to where we left off on the student book. All right, so number 4 on the student book, I think this is page 51, if I remember correctly. We're gonna try number 4 and number 5. Now, remember I started to say this before I went over that example. This is a 2-part problem. You have to be really careful with these ones. Make sure you read it carefully. This one says write and simplify. Now the word simplify means to make something more simple. That's exactly what we were doing earlier. Prime example is the one right here. So when you write something, you read it and then you write it. So this will be the first step. But then it says, and simplify. The simplifying part is taking it down to a more simple expression. And by simple meaning less terms. So somebody else might say, that don't look simple to me, but simple as in it has less terms than the previous one. So that's what you have to do for number 4. It's very similar to some of the questions in the homework where you have to read through it, especially like number 6 that we did in the worksheet.
Mr. Ray, are we on student book or what?
We're in the student book, yes.
What page?
I think it's 51. All right, so let's look at number 4. And I want you to try it out on your own, and then we'll go over it. It says write and simplify. Now remember, you want to try it. Don't be afraid of trying. If you don't try it, you will never learn how to do it. You have to really get yourself out there. You have to get over the fear factor and just try it. Don't be afraid of being wrong. Be afraid of not learning it. So everyone try it out. Number 4. It says write and simplify the following expression. The product. Think of what the word product means. You can use this table to help you out, right? We did that on Tuesday. The product of 5 and x multiplied by 6 less than the product of 3 and x. Now, at first glance, and first just hearing it, it may sound, overwhelming. But if you do it, just do it step by step. Do the first part, the product of 5 and x, multiplied by 6 less than the product of 3 and x, right? Just break it up part by part. When I do it over, I'm gonna do it in colors, but let's see if you guys can get the final answer. Okay, I have an answer from Maria, and I haven't worked it out yet, so let me see. See if I can do it in my head. All right, as long as you have, I can't say exactly yet, I want everybody to try it. If you send your answers privately, I can tell you if they are correct or not. I don't want to say yes or no if you send it to everyone. Very, very close, Alma. That's the first step, though. You have to write it. Now you have to simplify it. You just need a slight change. It says 6 less than the product. So let me review that again with you guys. This part here can normally throw people off, 6 less than. Remember, 6 less than the product, what you can do is use a real example. So if I had $6 less than you, and you had $20, then how much money would I have? If I had $6 less than you, and you had $20, how would you write that up to show how much money I have, right? Anyone wants to give it a go? What would be 6 less than 20? How would you write that? What is the answer?
14.
14, right? And we know that because we say 6 less than 20, we say 20 subtract 6. Now we know that in real life, we just need to apply what we know into algebra. Because literally, algebra literally is just a way to write down the complexities of life, right? How do we figure out something that has different things happening at once, right? We need a way to do it, and algebra is one of the most effective ways to do it. And so 6 less than something is kind of read backwards. 6 less than the number. So be careful. The order is really important when you're dealing with subtraction. So 6 less than a number means the number subtracts 6. All right, okay, I have 3 answers here now. And Veronica, that's correct. Well done. And Gennaro, actually, did you leave out something? Hold on real quick. I'm doing it in my head, so let me do a double check. Very close, Veronica. One thing needs to change. It says less than. Gennaro, that's correct. That's the first step, Gennaro. You just now need to go ahead and simplify it.
Okay. Okay. Let me see.
All right, Veronica, that's correct now. Well done.
don't know how to send my result. Wow.
Mr. Ray, I sent my answer. I don't know if that's correct.
Okay, I'll check it in a moment. I'm just sending some of these worksheets to you guys. So let me just, once I send this, I'll come right back over. So you guys should see at least the first worksheet. It has the distributive property, but it doesn't have the combination like what I was doing. But I'll send some more in a moment. Let me see. All right, that's correct. Salvador, I'm guessing that the underscore is a subtraction sign.
Yes, sir.
Okay, yeah. And Dorcas, that's correct. You just need to do the second step now. So you have written the expression. Now you need to simplify it. Simplifying is the distributive property. And I've sent everyone a worksheet on the distributive property.
Okay.
I sent the. I also sent the second one, Mr. Ray.
Okay, check it in a moment. Actually, I saw it. That one's going to be, you mean number 5 or number 5 as in the next question?
Mr. Ray, did I get it right?
Dorcas, that's correct.
Okay.
You don't want to add those, Alma. All right, so I'm going to start going over that in a few seconds. I just want to send something. You can't do it privately.
Okay.
All right, I'm just going to send one more worksheet over, and then I'm going to start that one. So like I said, the distributive property has come in, and then, no, we haven't got that part yet. Okay, so just the distributive property. All right, so let me come back over here. No, not that, where is it? Okay, so let's start off with the answers. Some of you guys have sent in answers. Some are very, very close, and some have slightly things that aren't quite right. So you definitely want to practice the worksheet that I sent on the distributive property. Okay, so like I said, there's a 2-part section here. You want to write first, you want to write it out, and then simplify. So it's a 2-part step. If it's a multiple choice, if you don't simplify it, then you're not going to get the full answer. But for fill in the blank, you actually have to write it in. And even in the GED, if it hasn't changed, when you write in your squares, they're going to prompt you to use the caret button just like I did. So just be mindful of that. All right, let's start this off. It says the product of 5 and x. So the product of 5 and x, hopefully you remember, The product of 5 and x is just 5x, right? And then it says multiply it, and put that in green, multiply it by 6 less than. So you're going to multiply this by 6 less than something. So you want to use the parentheses. And 6 less than means you will subtract
minus 6.
6, right? So what is that something that you are subtracting from?
X.
Product of 3 and x.
3x.
Which would just be 3x.
Okay.
And that's the color coordination. So if you did that part, that's correct. But now you need to actually simplify it. Now to simplify it is what we've been practicing earlier, distributive property. So we're going to take the 5x and multiply it into each term. So 5 times 3 is 15.
15.
15x.
And then the x times the x will give us
X squared.
13.
Oh.
And then we do the same thing. 5, remember, number with number, variable with variable. So 5 times negative 6 will give us negative 30. And then we bring the x. So that would be 15x squared. Subtract 30x. So some of you, a good bit of you who didn't get it fully correct, just forgot that square. And you had 15x subtract 30x. And then some of you going to simplify that more and say, okay, well, I have to subtract it. Be very mindful. Remember, when you do variable with variable, the laws of exponents comes in. You may remember me writing that. All right?
I got it.
Any questions there?
I'm good.
All right, number 5 is very similar, just a little bit more challenging. So try number 5 now. And same thing, you have to write it out first and then simplify it. So there's 2 steps, right? First, you got to read it, write it correctly, and then simplify it down to its simplest terms.
Minus.
Now, make sure you guys read it carefully. This one has a lot of different things in there. So try to break it up, right? A number times itself, added to the product of 5 and x. Then it uses a term that we just talked about, and that quantity is subtracted from the difference of 6 and x. So I try to color coordinate it for you. So a number times itself, that's what you want to do first. Added, that's what you want to do next, to the product of 5 and x. That's what you want to do after that. And that quantity, think about what quantity means. I introduced that earlier today. That quantity is subtracted from the difference of 6 and x. Okay, remember, in order to know what a number times itself is, we did that on Tuesday, but if you go to page 50, in that box, it can help you out. A number times itself literally means something like y times y, or 3 times 3, 7 times 7.
Mr. Ray,
yes.
I did it and I got a really crazy answer.
Well, it may look crazy. You want to share it?
Sure. I know it's wrong, but I'm gonna share it anyways. You want me to say it?
Oh yeah, you can say it. Let's hear it. I won't tell you if it's right yet, though. I want everybody at least to give it a shot. So go ahead.
You say a number times itself. So I put x times x equals x squared plus 5x minus 6x. So I came, then to the bottom was x squared plus 5x minus 6x equals 1x. So then I simplify to x squared plus negative x. I know.
I'm trying to do it in my head too with you.
Okay, Mr. Ray, let me give my
some
own.
elements that are correct there.
Let me give my own.
Need to refine it a bit. Go ahead, George.
Yeah, my own is x squared plus parentheses 5x minus 6x. Then for the answers, I have 5x cubed minus 6x cubed.
Okay, well, you were on the right track with the first part. The simplifying, you shouldn't get any cubes.
Because, okay.
All right.
Okay, yeah.
And, okay, I wrote you back, Sergio. All right, I'm gonna start this one because I do wanna finish off with something that's a little bit easier to kind of bridge you into a nice weekend.
Thank you.
All right, so number 5, I'm gonna just start it from scratch. And let me start off with red. Where's my pen? All right, so first off, it says a number times itself. So how could we write a number times itself?
Which is that number with, I think, half cube.
Not
we
cube.
We square the number.
X times X or B times B. Or A
right,
times
X times X, B times B. Remember, we did that right here. A number times itself.
X squared.
And we said X squared. All right, no problem, Sergio. And thanks for the update. All right, so a number times itself, which means the first thing we want to write in there is X. Hold on, I don't have the pen on. The first thing we want to write in there is X squared. Okay, then immediately after that, it says what?
Added.
Added. So what do I write?
Plus x.
Plus 5x.
So I have X squared plus, and then yes, it says to the product of 5x. So to the product of, I put that in orange, hopefully don't, let me change the color so it don't mingle with the red. I'll use blue. Add it to the product of 5 and x. So I put 5x. Now this is the part where it might throw a lot of people off, but I try to introduce it earlier today. and that quantity. Who remembers what I said you do for a quantity? If you took notes, it's at the very beginning. What I've even been saying it. Say it again.
You add those two?
No, quantity, something else. I said
Parentheses.
parentheses. So when we make something a quantity, we make it into a group. And so we group the terms
Quantity.
by putting it into a quantity.
Oh,
Right? So if you look carefully, so far, we're just going step by step. And I'm trying to keep the colors coordinated, right? X squared, red. The pink is the plus. The blue is the 5x, and the quantity is green. Okay, now the next part, it says, is subtracted from. So where does the subtraction sign go? Behind this quantity or in the front of the quantity?
Behind. Oh,
Behind, yeah, from. So it's from behind.
Well, let's try it out with a real number. If I said, I'm going to subtract $5.
Of 6.
Say that again?
From the difference of 6?
Yes, but we want to make sure we write it in the correct order because subtraction has to be in the correct order.
Mm-hmm.
So,
Minus?
Minus?
Yeah, it's a minus, but we want to know is the minus is here or is the minus here?
At the right.
Right there where you have it at now.
Okay, I hear on the side. Well, let's look at it. It says is subtracted from. So let me give you an example. If I say to you, I'm going to subtract $5 from your $20, how do I write that?
20 minus 5.
20 minus 5. Now remember, I said I was going to subtract 5 from your 20. But look how it's
before.
Right, so it goes before because I'm subtracting this from something.
Yes.
6x.
Remember what I said, algebra is literally just copying off of reality. So it's subtracted from something. And we want to know what.
So 6x minus?
X.
Well, first of all, it's subtracted from. So we know that whatever is subtracted from goes in the front.
6
minus X.
And then 6 minus X, right? Because literally the difference of 6 and X literally means the difference of 6 and X. Like you literally put the difference inside of 6 and X.
Oh, okay.
So that's what you get first, right? And if you look at the color coordination, hopefully it helps. I know it's mingling together now, but hopefully you can see it. So now that you've done that, you've done the first step. You have written.
I have a question. Can we also put it in parentheses 6 minus X?
You can put 6 minus X if you want. It's just that because it's separated by a subtraction sign, you don't need to.
Okay.
Remember I said that to you, if a subtraction or addition sign is in between it, well, yeah, just put it for, I don't want to throw too much rules on you right now, but you can put the parentheses there, but in this case you don't because you're subtracting the quantity. I don't know if that helps any, but hopefully with more exposure to this, it'll start to make sense. All right, let's go ahead and try to now simplify it. So to simplify this, remember, this could be -1. We just don't write the 1. Right? If it was -4, remember we are just practicing the distributive property. We would take -4 and distribute it in, but there's no 4, no number in front, so we know it's technically a 1. And if you need to, you can write the 1 in there. But we're going to distribute that inside, and we're going to end up with -1x squared, or just -x squared, and then -1 times the +5x will become -1 times 5 is just 5, and then the x. Was that part clear?
No, I'm not clear, Mr. Ray. That is, you mind -6 minus X.
I haven't wrote that part in yet. Right now, I'm only looking at the right side. Right now, I just want to make sure you understand the distributive property. That's why I wrote it right underneath it. I haven't touched 6 minus x yet. I'm writing right underneath so that you guys can see what's happening with the distributive property. Do you understand that part? The negative times x squared will be negative x squared.
Yes.
And that negative times positive 5x would be negative 5x.
Mm-hmm.
Okay. All right. So that means we still have this 6 subtract x there. And now we could collect the like terms. And do we see any like terms here?
X and the 5x.
Right. But we want to be very specific. Is it x and 5x or something else?
Negative 5x.
And
Negative x.
so
Yeah.
negative x and negative 5x.
Negative 5x.
Okay.
And we can combine those two together. And when we do,
negative 6x.
Yeah, we're going to get 6 minus 6x, or negative 6x minus x squared. And that is technically our answer. The only reason why I say kind of technically is because preferably we write them in what we call descending order or standard form. And standard form means you write the biggest exponent first. And so we write the negative x squared first. And remember, the sign in front of the number goes with the number. And then we will write the negative 6x second. And then the 6 is positive, so plus 6. All right. I don't know how it's written in your answer key. Let me go see. I don't know. More than likely, they wrote it in standard form. But let me just check. Generally, we always teach to write it in standard form. What number is this? Number 5? What unit is this? Oh, I'm in the wrong unit. Unit 3 and lesson 1, number 5. Yeah, so they wrote it in standard form. Negative x squared subtract 6x plus 6. And that will be your final answer. All right, so it might look challenging at first, but what you should do is try to see if you can do this again on your own. Get used to the language and knowing what the correct answer is. And same with number 4. You will see similar questions to that in the workbook. So after number 10, so what you can do is with the worksheet that I sent, and also now trying to do as much as you can after page 59. I know we're going to have an interesting weekend. It's Halloween and then election on Monday. So hopefully you could get some work done. But try to do the worksheet. Try to do these problems over, specifically number 4 and number 5. And try to do the workbook, the rest of the questions. All right, any other questions with number 5? All right, I'm going to do it from start to finish now, just to show you that with practice, it actually gets pretty easy. So can I clear this?
Yeah.
Yeah.
All right, and I'm just going to write it as I read it. So it says, write and simplify the following expression. So it says a number times itself. Well, that's x squared. I'm just going to mute everyone real fast. And let me just start over just to show you how with practice, believe it or not, you can get there. So it says, write and simplify the following expression. A number times itself, x squared, is added to the product of 5 and x. So that's 5x. And that quantity, so that's a quantity, is subtracted from 6 minus x. Did you see that? You're just reading and writing what is there. So what you want to do, like I said, is if you practice, and the GED is pretty straightforward, if you practice these terms right here, making sure you understand what the terminology means, then when they combine it together, all you're doing is writing them step by step. The only thing that's possibly left out there is quantity. And so just make sure you understand. And sometimes they might say grouped or anything of that nature, but quantity means to put it into parentheses. And that little scribble just means something is inside, right? Let me just write it. Quantity of x more than 3. Right? So a quantity of x more than 3 would be basically in parentheses x plus 3. So if you hear the word or see the word quantity, it's talking about a group, a quantity. Whenever you hear me say it, you hear me say something like 6x plus the quantity 5 subtract x. That's literally how I say things. And if you listen carefully, you hear me say that every single time. I say the quantity of. Okay, so back to number 5. You saw how fast it can be written through practicing that table. So making sure you know what the terminology, what a product means and all that stuff. Believe it or not, you can learn it very quickly. And then you just use your understanding of distribution. So we bring that in. 6 subtract x minus x squared, subtract 5x. We collect our like terms, we are at the negative, so that's 6 minus 6x minus x squared. And then we can rearrange them in order, remembering the sign belongs to the number or the term. So when we put the x squared in the front, we have to bring the negative with it. The negative 6x can stay, and that 6 is positive because the sign to the left is not there. And we know that when there's no sign, it's automatically positive. All right, so try to practice it. You just don't defeat yourself. You have to think positively. You might remember me saying your attitude determines your altitude. You might remember your teacher saying that. I remember my teacher saying that to me, and it used to drive me bananas. But then I realized they were right. Your attitude does determine your altitude. If you approach things positively, you're bound to do well. If you approach things, I can't do it, more than likely you won't do it. I've used this example. I can't remember if I used it with you guys, but imagine the United States of America finally makes it to a soccer finals, World Cup, right? And the person's about to do, they could win the game by shooting a penalty. If you know what a penalty is, it's just a goalkeeper and the player, and he just has to score it. And if in his mind, he keeps saying, I can't do this, I'm gonna miss it, I'm gonna mess up for the whole country, I am so hopeless. Watch me kick it over the goalpost. What more than likely is gonna happen when he tries to shoot the ball? He's gonna miss it, right? But if you ever watch, I don't know if you watch, I call it football, but if you ever watch it, you'll notice that they're very confident, especially people like, Messi and Cristiano Ronaldo and Neymar. They're so confident, they score almost every single time because they're just like, I'm going to do this, right? They have made up their mind they can do it every time. And once their mind is made up, then everything else follows. And so you have to literally make sure you have the willpower to do this, right? So I know I'm a human being. I suffer with that desire to say I can't, but you have to say you can. You can't fly. That's, you can't do that. But you can learn mathematics. You can do that. You can't walk up a wall like Spider-Man, but you can learn this information. And you can do well on the GED. And that's how you want to start thinking. You start thinking positively, then you see automatically, you're just going to start to see performance start to do better. I used to hear it all the time, but it wasn't until I started to do it that I realized, this is so true. Your attitude determines your altitude. So never get defeated. Say, I'm going to learn this. I'm going to go back and I'm going to take Mr. Ray's console because my console is not only research-based, but experience-based. First, I learned it by research. Then I experienced it, and I was like, this is so true. Should listen to what people have said. I wish I would have listened to my teachers in high school. I would have definitely made my life easier. But, I learned the hard way, and I'm trying to relate that to you guys. If you really want to do well, you have to put the time and effort. You have to study. Part of studying is reviewing what we've done in class. A lot of people say they don't have time. I used to work for a very strict principal. She should have been the CEO of Apple. But she used to always say to us, it's not that you don't have time. She used to say it really nicely. It's not that you don't have time, Mr. Ray. It's that you're not making the time. And I'd be like, I'm not making time. And it's true. It's, I'd rather watch TV or watch play a video game or something. Right. And so she used to say, just try to carve out the time. set that time. This is a real important event that you're trying to do. So the GED, you must pass it for a lot of you. And so you want to set a time. This time is for studying algebra. And algebra for the GED is like 50% of the test, which means if you really want to pass algebra, you have to master the basic skills. And just like I showed you, number 5 is literally just taking that terminology. But if you don't practice it, when it comes in the test, you're going to be like, oh man, I remember doing this in class. And you don't want that. You want to, I get on the test and I remember doing this. Oh, this is so easy. This A, B, man, this is a breeze. That's what you want. And that comes through willpower, deciding that I'm going to carve out 20 minutes a day. 20 minutes is literally enough time. If you want better scores, then a little bit more. If you could do an hour a day, you're bound to do well. There's a question in the statistics part, and it literally shows the GED's testing service did research, and people who study, I think, more than 9 hours for their GED literally do well. It's research-based, it's experience-based. You can ask any principal, teacher, you name it. If you do it, it's bound to have success. All right, so I'm saying that just in case you're just feeling down after doing number 5. Let's finish off with some easy ones, and that's the rest, believe it or not. Let's do number, hopefully it's easy. Let's do number 8. And I'm hoping number 8 makes you feel better if you didn't feel good about number 5. Because in my other class, they were like really upset. Like, oh man, I'm not gonna do well in this test. But like, yes, you can still do well. So number 8 says the width of Kevin's yard is 10 feet more than twice the width. So automatically, you want to start looking at it individually. 10 more than, what does that mean?
Plus 10.
Plus
10, right? So that means something plus 10. But what plus 10?
X.
Twice the width.
2G.
So
2G plus 10.
2G plus 10. And there we go, C. Now, number 5 was just literally the same thing, but they just had multiple things happening at once. And so you just literally had to just break it out one by one, step by step.
Mr. Ray, excuse me. Why do we have the 2G?
Because they tell you later on which expression below describes the width of his yard if G represents the width. So instead of 2W or 2X, they told you to use G.
Okay.
Right, so, but hopefully you're starting to see that. The more you practice it, so hopefully everyone can make the time between now and Tuesday to practice the worksheet, review what we've just done here. Hopefully you wrote down the answers, master it, act like you have to teach it. You know, I used to do that when we were in class. I'll say, you know what, all right, come up here and teach it to the class, because that literally makes you remember it more, or teach it to someone next to you if you're one of those nervous people. But try to do number 11 to number 28 in the workbook, page 60 to 61. Try to review these questions, see if you can do them again, explain it to somebody if you can. Say, do you understand this? If they don't, try to explain to them how to do it. You will help reinforce the concepts that are repeated in the GED test. And then last of all, practice the worksheet with the distributive property, making sure you know how to multiply into every single term. All right, hopefully I have inspired you to continue studying and to do your best.
Yes.
You can do well.
What page is on the workbook, Mr. Ray?
The workbook is page 60 and 61.
And
Page
one
60.
Problems, Mr. Ray?
Page 60 to 61. Repeat
Numbers.
Numbers 11 through 28, but number 22 will give you some trouble, so skip number 22, unless you want to try it. All right, go ahead,
Okay,
Salvador.
thank you.
You're welcome.
You answer everything, Mr. Ray.
Okay, perfect. All right, so just remember that your attitude determines your altitude. You can do this. Keep the end in view. The end is to pass this thing. And if you can do well in algebra, and you don't have to become a teacher in algebra, just enough to do the basics, you should be fine. Just keep positive, stay positive. Stay safe, of course. This weekend, like I said, could be interesting with Halloween and then the election. So stay safe. Hopefully I'll see everyone on Tuesday. And
Mr. Ray.
if you have any questions, send me a message on Remind. Yes.
Thank you. Thank you for the
You're welcome.
encouragement. I'm having a really hard time with this.
Don't
And
worry.
I was getting bummed out. It's so difficult.
Yeah, it is. It's
I was
challenging.
feeling the same.
But thank you. I appreciate all your time and your encouragement, and I'll try and do better with
Yeah.
making time.
One step at a time, making time, just trying to find that time. And you can do it. I believe you guys can. I'm seeing what you can do. It's really, don't worry, it's not a math gene. It's just, you know, trying to build up a new way of thinking. That's all.
Hey, another quick question regarding because it's not as expedite when we text. What's the issue? Is it on the GED web page when I sign up, or here at Zoom that you see that nickname?
Oh, that's on Remind. It's coming up as block. So I was
Really?
like, yeah.
On Remind.
If you don't mind, I'll show you real fast. I'll reshare.
Yeah, please, because I don't understand.
And I already had a troll come into my Zoom class, so I was like, a troll, you know, somebody comes into your thing and says crazy stuff. So when I saw this, I was like, who is blah?
What in the world?
Yeah. So I'm not sure what happened.
So
that's why I wrote you
wow.
that message.
Well, I'm sorry that's there. I have no idea.
It's probably not you. Sometimes glitches happen, and it
But
could be somebody else's.
this is that message that I just sent you. That's our conversation. So
yeah, are we talking about Zoom, etc.?
Okay, then I'll check into it. So it's Remind. Thank you.
Yeah, but now that I know it's you, I mean, it's not a big deal. I was just like, who is?
No,
Bob?
that's crazy. I'm gonna try and change that. I don't know how that happened.
Yeah. All right, no problem.
Have a blessed
Okay,
night,
Mr.
y'all.
Ray.
Yes, you as well. Blessings to you
Thank
guys. Be safe.
Thank you so much. See you Tuesday.
All right, Gennaro, be safe.
Okay,
Thank you.
Tuesday.
Thank you, Mr. Ray.
You're welcome.
Thank you. Have a good weekend.
Good
As
night.
well. Enjoy your weekend.
Yeah.
Good night, Mr. Ray. Thank you.
All right, you're welcome. Bye. All right, William. All right, any other questions? I see some people lingering. Not sure if you have any questions or not. Okay, if not, I'm about to end this meeting. All right, bye.